So regarding logistics for the question and answer session, please type any questions that you might have into the chat box at any time during the talk, or raise hand during the Q&A session, and our volunteers will unmute you to ask your question. They'll also monitor and make sure that audio of the audience is muted during the talk. So with that being said, welcome to this keynote presentation at CDSE Days 2021. My name is Ranga Settler, and I'm the co-director of the NSF Center for Identification Technology Research here at UB. It's my pleasure to welcome today's speaker, Dr. Sriganesh Madhvanath. Sriganesh, or Sriji, obtained his bachelor's degree in computer science from IIT Bombay and obtained his PhD in computer science and engineering from UB, and has been a colleague and alum of UB's Center of Excellence for Document Analysis and Recognition. He has since led applied research teams at IBM Research, HP Labs, Xerox PARC, and Conduent Labs prior to joining eBay. He's currently the Director of Applied Research at eBay. He's an ACM Distinguished Scientist and a senior member of IEEE. His research interests are primarily in the areas of data science, AI, and human-computer interaction. His talk today will be on building large-scale listing recommender systems. So warm welcome to you again, Sriji. The floor is yours.
Thank you, Ranga. So yeah, welcome to this presentation. I thought I would talk today about building large-scale recommender systems from an industry perspective, where there are a lot of practical considerations that we have to take into account. And hopefully you'll get a sense for that as we go through this talk. So like Ranga mentioned, I lead the applied research for what we call merchandising, which is another name for recommendations. And we are part of a larger advertising initiative at eBay. So at eBay, advertising comes broadly in two forms. If you go to our website, you will see ads from Geico and other kinds of a third party, so that's called third party advertising. But you also have an ability for our own sellers, people who are selling on eBay's platform, to promote their merchandise by paying ad fees, and that's called first party advertising. And that's where the focus of our merchandising is primarily. So again, you'll get a sense for that as we go through this. So a little bit of context about eBay itself. So eBay, as many of you may know, is one of the pioneers in e-commerce. I think finished 25 years recently. It has always been a marketplace from the very beginning. So it is not like another e-commerce site where they are warehousing different goods and selling them to buyers. It's a place which connects sellers and buyers, and it's sort of the one that makes this kind of connection possible. So another interesting thing about eBay's data is that because it's a marketplace, we don't have what you would think of as product pages. So if you go to another site like say an Amazon.com or a Walmart.com, a product would have one page on that site. We are something more like a classified site or a Craigslist, where each seller can list something that they have for sale. And therefore, you may have multiple sellers selling the same thing. So that when I say listing, I really mean an offer from a seller to sell something, right? And we have 1.7 billion of these. And this is data from the last quarter of 2020. We also have 185 million active buyers worldwide. And we are in 190 markets. So people in 190 markets can actually shop on eBay. We also have close to 20 million active sellers. And a few years ago, the sales volume on mobile devices actually surpassed that on desktop. So in last quarter of 2020, we had about $17 billion of sales happening on mobile devices out of a total of 27 billion for that quarter. Okay, just to give you a sense for how buying patterns have shifted over to mobile devices. It is a platform where there is a lot of activity happening, and this slide just gives you a sense for the velocity, how many transactions are happening pretty much every second on the site. And the other thing which is hard to know once when you're just a shopper, But once you're part of the company, you realize that eBay is as much or even more about the sellers than it is for the buyers. So the model of the company is really about empowering people and creating economic opportunity. And like we said, there are about 20 million sellers, and this is all the way from consumers like you and me to small mom and pop shop kind of businesses, small businesses, large businesses. Many of them make their living off this marketplace. So that commitment to sellers has always been the case, and for that reason, eBay is not in the business of manufacturing. So it doesn't make any goods that actually compete with its own sellers. It's purely 100% marketplace. Again, another thing that it does for its sellers is gives them a global audience of buyers. So 96% of US eBay small businesses, for example, export on average to 17 export markets. So again, it's able to take a small business here and give them a global audience. So now coming to AI at eBay. Now, e-commerce is a pretty rich space for artificial intelligence. Obviously, you can think of searching and recommending. As a buyer, those are things that you would do. You would search for things, and you would expect to be recommended things. There are a lot of applications for computer vision as well. So we tend to think of these applications as either buyer-facing or seller-facing. As a buyer-facing application, an example may be you can take a picture, and this is something you can do with eBay's mobile app. You can take a picture of, say, a handbag, and you will be shown similar listing on eBay's site. So it's using computer vision to do image matching. On the sell side, you can imagine, and this is something we're still working on, the goal is that eventually you should be able to hold up a book and say, I want to sell this. And it should just be able to use computer vision to extract all the information about the book, whether it's the title, the author, all of that information should be picked off from just the image. Right now, we are using images for things like counterfeit detection, right? So a lot of applications for computer vision. Machine translation is huge because you can imagine, let's say you're a seller in Germany and you've listed something for sale in Germany with information in German, but you have the ability to ship to many other markets like the US. You would want your listing to show up on the US site with English titles and English information. So again, there is a big demand for machine translation to translate item information typically from one language to another. And there's, of course, personalization, economics, logistics. These are other areas where AI machine learning is applied. So coming to the topic of today's talk, which is really recommendations, what do we mean by listing recommendations, right? And I think maybe the best way to answer that is to actually show this to you on the live site. So you can all hopefully see my screen. Sorry about this. Yeah, so here we are on eBay's homepage on the desktop, and you can see here there are a bunch of these. These are all listings. Each of them is a particular offer for something from a single seller. And you can see that there are a bunch of different recommendations here for me based on recent activity. So I've been looking for a mailbox for my home because the last one broke. So I've got recommendations for mailboxes. I've been looking for smartwatches, cell phones, so these are all recommendations which are personalized for me. Now, if I go and click into one of these recommendations, let's say I click on this shoe over here. So what that does is it loads a listing page. Now, this is a page where this pair of shoes is been offered by this seller, and you can see the seller's reputation here. You can see the condition, new with box, right? You can see price, shipping, other kind of information. Right below that, you can see the strip of listing recommendations. The idea of this strip is for a buyer who's considering buying this pair of shoes, which we will call the seed item or the seed listing, these are things that the buyer may want to consider as substitutes, right? So those are called similar sponsored items. And similar here indicates that these are similar to the seed item. Sponsored indicates that the ranking of these items has been modified slightly based on some sort of promotional fee paid by the seller. So legally, there's a requirement that you have to distinguish those from listings where there has been no such fee paid, so no such promotion. So these are all sponsored. Now, these are sponsored items from the seller. So they're not necessarily similar to the seed item, but they're from the same seller. After this, you have information about the item. This is all coming from the seller, right? After that information, you will see more recommendations. Now, this is sponsored items based on my recent views. So you can see it has some cell phones, some shoes, and it has another set of recommendations, which is actually helping me explore other shoe models, right? So the other brands, other kinds of activities like hiking. And now I have some more recommendations which don't have the word sponsored in the title. These are what we call organic recommendations. So this one is not been promoted in any way. Here we are using all of eBay's inventory and we are showing you recommendations based on that. This is people who viewed this item also viewed. So it's kind of similar to the similar sponsored recommendations. More from the seller is again very similar to more from the seller that was sponsored, and this is not. So that's a big difference. So you see about 6 different strips of recommendations, and each of this is a different recommendation algorithm. Now, the context for these recommendations is, of course, you, the buyer, but it's also the seed item, right? That plays a huge role in deciding what we should show on this particular page. So hopefully that gives you a sense for what we mean by listing recommendations and what we mean by recommendation context. So on the home page that I showed initially, there was no seed item context. It was just you, the user, and maybe things like, which country you're shopping in. Other context could be the time of the year. For example, at this time, maybe we should be showing you things related to outdoor activities because you're just starting to do that. So that would be the context. Whereas on the listing page, the seed item is a large part of the context. Okay. This is sort of the big goal for recommendations, right? And in the eBay context, because it's a marketplace, it's sitting in between the buyer and the seller. For the buyer, we want to try and be sort of a personal shopper. You've got 1.7 billion listings on eBay, and you're looking for something fairly specific. How do you navigate this vast inventory? And that's where recommendations can really play a huge role, along with search. Now, you can come in and search for things, but then recommendations can also help the buyer explore that space and make that more efficient, right? Streamline that purchase journey. And also, like we saw with the sponsored recommendations, it can also give sellers a way to promote their listings. Imagine a seller trying to promote something for the first time, a new listing, a new product that they're trying to sell. Then this gives them a way to actually get that in front of buyers. Okay. And this is especially true in the case of eBay because you've got a lot of weird and wonderful inventory on eBay, right? It's not like your typical e-commerce site where you have mostly, things that you would buy, which are more functional in nature. eBay is a place that a lot of hobbyists come, coin collectors, right? People interested in different kinds of hobbies. So it's all the more important for sellers to be able to showcase the uniqueness of their inventory. Okay, so now moving into the scale of this, and I mentioned in the beginning that a lot of this is about scale. So our recommendations are on a lot of different pages across the site. Now I gave you 2 examples. I showed you the home page, I showed you listing pages, but you can imagine, let's say the checkout page, you've just bought something. You bought, let's say, a camera. There you may want to see recommendations for accessories like a case for the camera or lens for the camera. So on every page in eBay, you can think of maybe use cases for recommendations. So that's why we have so many placements, and not just on the site, but also, for example, in email. After you've completed your purchase, maybe a month later, you're interested in accessories or something. So you may expect an email with some recommendations in it. And this is across 4 platforms, which is basically your desktop, your mobile web, which is how you access eBay through a web browser on a mobile device. You also have Android and you have iOS. So that's 4 different platforms and all these different regions. So we are serving 4 billion impressions a day, an impression being an instance of this strip of recommendation. So this is huge scale. And I think a lot of you are, data science, in the data science field. So you would probably have some exposure to recommender systems. Broadly, there are these 2 paradigms, and One of them is collaborative filtering, where you have a matrix of all the users and all the items. And the way it works is you have two users who exhibit similar behavior. For example, they both read the same articles. Then you can recommend to one user, you can recommend to this user something that this user has read, right? Because they seem to exhibit similar tastes in articles. Notice that this approach doesn't care about the content of the article. It just cares that two people have been reading the same articles, right? That's collaborative filtering. In content-based filtering, there you actually care about the content of that article. And you're saying, well, the seller read this article, or not the seller, sorry, this user. So then articles which are similar to that article are probably interesting. So you will recommend other articles based on the content. So broadly, these are two approaches. And in practice, it's often a blend of these that is used. Now, coming to doing recommendations at eBay, right? What makes this so challenging? So one thing I mentioned upfront is we live in a world of listings and not products. If you take, a good e-commerce site, maybe they have 1 million products on sale, right? A larger e-commerce site might have 10 million products. A big site may have something like 100, 200 million products. But still, when you're talking about 1.5 or 1.7 billion listings, we are talking about 1, 2, 3 orders of magnitude more things that we can recommend to buyers, right? And then we also have this huge number of buyers. So essentially, you end up with a user item matrix that is extremely sparse. With that being said, collaborative filtering approaches, the classical ones, typically don't work, on this kind of data. Then you have volatility. So listings come and go. So half the listings at eBay are what we call single quantity listings. That is, there's only one of that thing. Once it's sold, it's gone, right? Unlike a product which is stable. And also you have new listings that come into the marketplace all the time. So imagine in this one, you've got these columns that are constantly appearing and disappearing in this matrix, right? You also have the lack of structure. So this has been a big challenge. Imagine you have a book, you have some way to like a ISBN number, which uniquely identifies that book, right? Or for a product, you may have a UPC code. Even if you don't have such codes, you may have metadata, like let's say this iPhone is made by Apple. It's an iPhone 12. It has, say, 128 GB of memory. So there are these different structured metadata I can try and capture about it. These are basically name value pairs. The seller needs to provide us with this data, or needs to at least map their listing to a product in a catalog. And this is something we've only had mixed success with. So some sellers provide that data, some sellers don't. And with something like this, you can imagine, like a phone, I can have a pretty finite set of metadata. But if you take something like fashion, right, or you take something like an autographed baseball, it's very hard for us to prescribe exactly what metadata should describe that object. So we've essentially left it open to sellers to create their own tags, their own names and values. But that, of course, that flexibility also means that we have a lot of non-standard names and non-standard values for those things. So the point is that we don't have a lot of structured data about these listings that we're trying to recommend. There are also, missing inter-entity relationships. For example, how do I know that a particular cover fits a particular iPhone? Like that is a structured relationship that often I don't have in the data. The seller is not telling me that. So we have a lot of those issues. And then, of course, what makes eBay truly interesting is really the diversity of item conditions. So this particular iPhone, I can get it brand new in box, I can get it open box, I can get it slightly used, heavily used, refurbished, broken, and for parts only. So there's this whole variety of item conditions that's not available anywhere else. There's also purchase formats. You have some sellers saying, they will sell this to you for a fixed price. Some people have it up for auction. Some people are saying buyers can make offers. So we support a variety of purchase formats. And because it's a marketplace, we don't control shipping times. Two sellers, one seller may ship it to you in 2 days. Some other seller may ship it in a week, right? And there's also great diversity of sellers in terms of their location, reputation, and various other, attributes. So this basically is what makes the recommendation problem using EB data kind of different and much more challenging compared to many other marketplaces. So now to get into some of the technical approaches that we have adopted. So let's take the listing recommendation problem, the example I gave you of like, here's a sneaker and here are a bunch of similar sneakers that I want to show you, the buyer. How do we go about finding these things to show you? So we have come up with essentially a strategy of recall followed by ranking. The recall stage is where we try to find relevant things, right? Things that you may be interested in as the buyer. So things which are, in this case, for this algorithm, similar to the seed item. So this is my seed item, and I'm trying to find in this 1.7 billion listings, items that are similar to the seed. Now, if I had good metadata, I could say, well, give me something by the same manufacturer, the same model, etc. But if I don't have that, I am trying to use other techniques. For example, title similarity. So you saw that every listing had a title. Now you're talking about unstructured data. You have an unstructured title for the item, and all listings have titles. So we are trying to do similarity matching on item titles. You can also look at data such as co-views. So for example, if another pair of sneakers was viewed along with this pair in the same session by a lot of buyers, that suggests that maybe that is similar to this one, right? So here you're using behavioral data. It's nothing to do with so in a sense, it's just collaborative filtering because you are using that kind of data. So you can use co-views, you can use co-searches. So that means that buyers search for things in the same session and clicked on these two items as a result of those searches. That suggests that maybe these items are similar, right? So these are all different approaches or strategies we use to find from this huge number of listings that may be similar to the seed, right? And there's no guarantees here. You're just trying to find things that may be similar. And then we have a ranking stage where we try to rank these. Let's say I found 1,000 items which are similar. Now trying to rank those because I have limited real estate on the screen. I can't show you 1,000 items. I can only show you 6 items. So here we look at, of those items, which are the ones that buyers actually bought, right? So this third item, let's say, is what some buyer purchased. Now that is a signal for us that, okay, that's a good item to recommend given this particular seed item, right? So that's broadly the framework that we've developed. This is just an example of a recall set based on co-views. So like I said before, these are listings, also called items that have been viewed together in the same user session, right? So which suggests that they are maybe similar. And you can restrict this based on the type of recommendations. So for example, if I'm trying to recommend to you things that are similar, I may say they have to be from the same category. So then you would only get shoes when you're looking at shoes. Or I can have a restriction saying they must be from a different category. Then maybe you'll get socks instead of shoes, right? Because socks are also co-viewed with shoes. So this is how you would get different kinds of recommendations. Here's an example of like a Harley Davidson leather jacket for women, and that's a seed item. Now, if you do cross-category co-views, you may end up with like a pair of boots and some sort of a shirt, right? So these are cross-category co-view based recommendations for this seed item. So that is the recall stage. Like I said, now we've got 1,000 items based on our recall strategy. How do we rank them? And here, the simplest way to think about it is, think of it as a binary classification problem. There were things that the buyer didn't even bother clicking on, and then there were items the buyer actually clicked on and purchased. So you can think of this as a binary classification problem, and you can train a machine learning model on these seed item and recommendation candidate item pairs. So we typically use, depending on the complexity of the model, anywhere from 10 to 100 million training samples, which are basically pairs like this. And we use hundreds of factors. So we use a lot of different features, and we provide them to the model, and the model, of course, automatically selects some subset that are the most informative for the problem, right? We are not trying to dictate to the model what features are important. We let the model pick that out. And we've looked at various ML models, gradient boosted trees, XGBoost being a popular implementation is the one that is used most commonly in production. We're also looking at some deep networks. And what the model provides is really a score which indicates the probability of purchase, the probability that this item will be purchased by the user given the seed item context, right? So this is some examples of features that we are using right now. There are some features of the candidate that I'm trying to recommend. For example, the price, right? If this thing is overpriced, probably it's clearly an indication that is not going to sell. So clearly price is an important feature. Popularity, the reputation of the seller matters a lot. Then you also have features which compare this candidate to the seed item. So how common are their titles? How common are the whatever structured data we have about them? Are they similar? Are they different, right? So those are features based on similarity between the candidate and the seed item. And we can also think about similarity between the candidate recommendation and the buyer. So for example, price propensity. I could be showing you similar items for, say, a watch, and I can recommend expensive watches, or I can recommend less expensive watches. If I have some data on what is sort of the typical kind of price this buyer pays for a watch, right? I can try to make them more relevant for you. So that's called price propensity. Gender, obviously. So these are user features which personalize the ranking. Imagine if I took these features out of the model, every buyer would get exactly the same ranking, right? All else being equal. But it is these features that actually lead to different buyers seeing different recommendations. So that's our ML approach to this. So now, how do we put all this together, right? I mean, this picture is a little complex and busy, but I'll try and walk you through this. So if you're the buyer, right, you've just come to this listing page, you clicked on this item. From a system perspective, this is the seed item. The context would be you are the buyer, this is the country, this is the time of the year, all kinds of context along with the seed item is sent to our service, which we call the merge front end service. And that is passing it to the back end where we have all these recommendation algorithms. So there's a module in the middle, which is trying to decide for a particular buyer in this context, what are the best set of recommendation algorithms. Like I showed you different strips there. Each of them is a different algorithm, right? So this block here is trying to decide of those different algorithms, which are the best ones to show you. And we don't have time today to get into this, but this is again based on some machine learned models. Once that makes a decision, it's basically calling these different algorithms. So this is the similar sponsored items that I showed you. It has got item recall, a stage which is using strategies like title keyword similarity. It's using co-views, and it is querying our item repository. This is where our 1.7 billion items live. And it is trying to find a set of similar items, right, using the recall strategies. And those items are being passed, or some top K are being passed to the item ranking stage, which is using this machine learned ranker, right, to rank those items. And in addition to the features that it needs for item ranking, it is also receiving the ad rate that a seller may have paid. Now, this is only true for the sponsored listings, not for the organic ones. The organic ones, there is no ad rate. But for the sponsored ones, there is this ad rate which a seller has paid, which we are going to use to influence the item ranking, right? Once those recommendations are ranked, we can take the top 6 or 12 or how many ever we want, and we have space to show. And those recommendations are going back. They are rendered, right? Because if you're rendering this on a web page, you need them to be in the form of HTML, CSS, JavaScript. So that goes to the web page. If it's going to a native application, then the native application is doing the rendering, right? So these recommendations are showing up for the buyer. The buyer is now interacting with these recommendations, right? The buyer may click on some recommendations, and that data about what the buyer viewed, what the buyer clicked on is being collected, and then you are merging it or joining it with purchases. So notice that buyers are not going to necessarily purchase some things on the spot. A lot of buyers will say, add something to cart. They may come back after a week, they may come back after a month and complete the purchase, right? So those events may come significantly after the click event. You also have something called bad buyer experience events, right? So imagine you, the buyer, bought something, this pair of sneakers from a seller, and it never arrived, right? You waited for it for a month, never arrived. The seller said 2 days, it didn't come. Or what came was significantly different from what was advertised, right? So these are examples of bad buyer experiences. And that kind of data also is collected, typically reported by the buyer, and that data also flows in. And now we're using this data to create our training samples. So like I mentioned, items that were shown but not clicked on would be your negative samples. Items that were clicked on and purchased would be your positive samples. So those go into your machine learned ranking. This is a simple example of how you would create a two-class classifier for ranking. You can expand this to more classes. So for example, you can say a purchase is a certain class, a click is a certain class, an ignore is a certain class, a purchase followed by a bad buyer experience is yet another class. So you can have a multi-class kind of problem, which this particular ML is trying to model. And that is essentially what's used in item ranking. Here you have a different algorithm, which is related items, or think of it as like complementary items. It may use a different recall strategy. It may use different features, but the principle is still the same. There's a recall stage and a ranking stage. So it really starts to look more like an information retrieval problem than your classical recommendations problem. And it's actually very similar to search also. So the way you do search is again using a query. In our case, we're using some seed item as a context, but in search, you would use a query to do the recall followed by ranking. Okay, so hopefully that gives you an idea of how all these things come together. Now, as you can imagine, the data science is not sufficient to get any of this working. You need a lot of engineering. And this just gives you like a quick view of some of the technologies we're using. But essentially, we've got these recommendation algorithms deployed on literally hundreds of servers in data centers with failover and all the other things to make sure that these things don't go down. They're always available. There's high latency because these need to surface typically in 150 to 200 milliseconds. If they don't surface within that time, your buyer is not going to engage. The buyer is not going to wait around for recommendations that take a long time to appear, right? So this is the engineering infrastructure that makes all that possible. So at least at eBay, we have a fairly small team doing this work. In larger companies, you may have like a dedicated science team, which is developing the algorithms, and a dedicated engineering team. In our team, it's just one blended team, which does the data science and does the engineering. Of course, we do have people who are specialized in one or the other, but we do expect great software engineering from everyone, regardless of whether you're a data scientist or not. So that's production engineering. Then I want to touch upon what's happening now, which is the last few years. I don't need to tell you this, but deep learning has really come in a very big way in every field, and recommender systems is really very much the same. And you can think of many different places in the system I described where you can use deep learning. You can use it to do more intelligent recall. You can use it to do more intelligent ranking. You can use it to model users. So some of the examples, and what deep learning really allows us to do is solve the representation problem, right? The semantics of text. So let me give you an example. If the seed item was a red round living room cushion, right? Let's say that was the title of the item. And one of the candidates I'm considering recommending is a maroon fashion pillow. If I was just doing some keyword matching, I would not even realize that these two are related. But now with text embeddings, I can maybe understand that red and maroon are related and cushion and pillow are related. So it gives me new ways to relate my inventory, which I didn't have below before, using the semantics of text. Not just text, I can now look into images, video uploaded by sellers. Images are particularly interesting because they're also indicative of condition. Like one of the challenges we have now is a seller says this is a used item, but used can be anything from gently used to heavily used. And we really have to rely on the text description. Imagine you could actually start to look at images and try to understand the condition of items, right? So that's something deep learning allows. Short and long-term user interest. This is a very hard problem. So as a user, I may be shopping for an iPhone today, but that doesn't mean I'm going to be forever interested in iPhones. It's a short-term interest. It's a short-term shopping mission. A long-term interest I may have, maybe a hobby, right? Or if I am in a certain family circumstance, let's say I've just had a child, then I can imagine that there are going to be certain things I'm going to be shopping for the next few years. So understanding those kind of things, again, based on user activity on the site, is something we can try to do with deep learning. There's also shopping intent. I think this is related to what I said. What is the intent of the buyer? Why are they here on our website today, right? So in HCI literature, you talked about mixed initiative systems, where the user is taking some initiative, the system is taking some initiative, and together they are trying to solve some problem, right? So that is the goal here as well. We are not there yet with our recommendations. They're still fairly static, but imagine they're there to help. And this is where it is very important to get it right. Like I'm sure you've all had that experience of going into a big department store, and there's some sales folks who are, constantly showing you things which you're not interested in, to the point where you're saying, just leave me alone, I'm just looking, right? And then you have people who are watching, you are observing what you're doing, and they are making really helpful suggestions. So recommendations is the same thing with recommendations. It can really get in the way, or it can be extremely helpful. And understanding the shopping intent is a big part of that. Non-obvious relationships between items, for example, in fashion, right? We have the sense as humans of these two things go together. When you put out, like you're trying to decorate your living room, or you're trying to pick an outfit or whatever, what is that, right? How do we relate those things? How do we say that they go together? Again, we can try to learn using deep learning. And what matters to users in context? Sometimes a surprise that matters. If I'm shopping around Christmas time, maybe the most important thing is that it arrives in time, right? So the shipping speed matters there. Sometimes it's the brand that matters. So understanding what is important to the user in context is, again, something that we can try to do with deep learning. The challenge, of course, with deep learning is that it requires vast computational resources and huge amounts of data to train. So let's say I need 10 million samples for my gradient boosted tree model. I need maybe 10 times or 100 times as much data to train a deep model, right? So that's typically the difference. So this is I just wanted to maybe end with this slide, which is give you a sense for some work we're doing in deep learning. And you can find details, this link here. So we recently put it on archive. What we're trying to do here is we're trying to come up with a way to recommend things to buyers based on their activity. And this could be activity over the last week, the last month, last 6 months. So it's a window that we can customize. And I think we call these personalized item recommendations, because there's no seed item here. We're just recommending things for you, the buyer, right? So the core idea is that if we can represent buyers and items in the same vector space, then we can reduce this to essentially a nearest neighbor search problem, right? So if the users and items were in different spaces, then it becomes a harder problem. But if you can put them in the same space, then I can use L1, L2 distance, some standard measure of similarity to find recommendations. So the way we went about this is using a two-towered network. This text on this may be a little hard to read, But on the one side, we have user embeddings. So this is a recurrent neural network because sequencing is important. This is observing user activity on the site. So let's say you clicked on a certain item or you searched for something, you bought something. That sequence of user activity is what is represented here. And then on this one, on the right side, we have some attributes of the items that you've been interacting with. So mainly, this is the title embedding. So we learn to embed the title of the item. We look at the structured metadata we may have about it. Often we don't have much, but we try to use what we have. And then the category that it's in. For example, it's in men's shoes, for instance. So those together form a candidate item embedding. And we're training this network to learn these embeddings in such a way that if the item embedding is close to the user embedding, it's more likely to be relevant for you. You're more likely to purchase that, right? So that's what this deep network tries to do, learn an affinity between users and items, like I described. So again, this is just an example. I mean, we're working on deep learning for other places, including ranking. But maybe that's a different talk at some other point. So I'll actually end with that. So some of the things that I hopefully gave you an idea about is how do you build recommender systems, commercial recommender systems, some of the unique challenges presented by e-based data, how we're using a variety of techniques and data sources for recall, and how we use machine learning extensively for ranking, right? I mean, a lot of people suggest, why don't you use this feature or this rule or this heuristic approach? But what we've found in practice is giving this machine learned ranker a lot of features. The features are, of course, hand engineered today, and letting the MLR pick from them. That's a better approach. Now, once you go to deep learning, you don't even need to hand engineer features. You can throw a lot of raw data at it and have it construct features automatically. And I made this point also about, it takes a lot of engineering. This is not data science by itself. It takes a lot of engineering to build and deploy these systems at scale. And like I mentioned, deep learning holds a lot of promise for everything: deeper understanding of users, the inventory that you have, shopping contexts, and the relationships between them. So yeah, if you're interested, please do look at our tech blog, eBay's tech blog. We regularly have articles about just different aspects of technology at eBay, recommendations being one of them. And also we have a career site. So I'll leave you with that and happy to take any questions.
Thanks, Sriji. That was very interesting. Are there any questions? If you have questions, you can either type it in the chat window or you can unmute yourself and ask the question of the speaker.
So I've
got one, Sriji. This is Bruce.
Yeah.
So you mentioned this in your talk. You're trying to make a recommendation for a potential related purchase. There are lots and lots of other factors that go into why I'm on eBay looking for a particular product. What's the thinking of you and your team about how you try to learn some of those other factors and features that affect my buying purchase here and what I might else be interested in? I mean, how do you learn that stuff?
Yeah, so there are features that may have driven you to try and look for that thing on that given day, right? Which are external to eBay that we have no visibility into, right?
Yep.
That really, honestly, there isn't much we can do about that. But what we can try to do is correlate it to your previous behavior on the site. So for example, let's say you bought a camera, a high-end camera on a certain day. That makes you more likely to purchase, like, say, a lens for it, right? Maybe a month down the road. Now, this is not something that we would try to capture as a rule, But we would say, you know what, there seems to be some interesting correlation there. So let me create a feature, which is how related is this particular recommendation candidate to a previous purchase in the last 90 days, right? So I could create a feature, throw it into this big bucket of features that the machine learned ranking is trying to use, and see if it picks it up. So we would give maybe 100, 200 features to this. The ranker would automatically select or give weights to these different features. And we may say, okay, you know what, let's just take the top 50 features. It turns out this particular feature I just created is in the top 50, then you will start to see that behavior in the ranking, right? You would start to see recommendations show up which are related to your previous purchases temporarily, right? But if it's not in the top 50, then you will not. And the reason we picked 50 is often for reasons of computation. We need to compute this ranking and get back to you in 100 milliseconds, right? So that's often the reason why we kind of make these decisions. I hope that gives you a sense, but we don't really have a lot of visibility into what you may be doing outside the site that may have triggered this purchase.
Yeah, exactly. There's so many other factors that go into that decision to purchase.
Yes, and there are obviously a lot of privacy kinds of issues with that too. So we largely restrict ourselves to what we can observe on our site.
Thanks.
Yeah. I see some questions in chat. Should I try to?
Sure. Go ahead.
So this is, as we compare seed item with all items or similar items, since you mentioned 1.7 billion across, we will search. I think the question is about how do you do this efficiently, maybe. So you would need to build indices. If you're trying to, for example, look for all items that have titles similar to the seed item, you would need to build a massive index that's letting you do that efficiently. Similarly for other things, if I'm trying to find all items that have been co-viewed with the seed item, again, I need to have that data in some high performance database, like we use Couchbase for a lot of things, to efficiently pull that recall set, right? So that's part of the engineering side of the story. Any thoughts on how recommender systems can be built to also promote poorly performing eBay listings? Yeah, so the current setup seems to be heavily skewed towards promoting popular products. So it's, let me answer it in two different ways, right? Knowing, we don't know a lot about, let's say you as a seller decide to sell something new today on the site. We don't have a lot of information about this product. It is just a safer choice. And it's not a choice we are making, it's a choice the machine learned ranker is making. We are giving it features, one of them being, let's say, previous sales statistics. How often has this particular item sold in the past? It is relating that to purchases, and it's trying to say, or it's learning the fact that popularity actually matters, that popularity is an important feature that influences buyer decisions, right? So it ends up giving it a big weight. So it's not like we're designing the system to promote popular items, but there is a correlation between popular items and things that the buyer wants to buy. There's something that we didn't invent. But what we try to do, though, for new items, so there's again one more nuance to this, which I didn't get into this. You've all heard of the explore exploit paradigm, right? If I was only to recommend items to you that I knew converted well, and I have 1.7 billion listings, there's going to be a lot of inventory for which I'm not going to get any data at all. I don't get any signal from the buyer about how the buyer would, interact with that item. So what we do is we take some percentage of our recommendations, let's say 10%. And instead of showing you things that will convert well, we will show you random things from the inventory. So what this does is it gives us an opportunity to learn something about that data, about those items, like would the buyers actually buy these things, click on them, etc. So that's something we do with new inventory, like we can basically make it part of the exploration. The other thing that sellers do with new inventory is actually use promotion. So if you're a good seller with a good reputation and the item is highly relevant, well priced, it's a good item, then chances are with a little bit of ad rate or ad-based promotion, it will actually surface. So those are different strategies we have for new products. Another question was, like we have item-to-item recommendations, how do we find similar users for user-to-user recommendations? So yeah, we're not actually explicitly doing user-to-user recommendations, right? What we're trying to do is we're using it in a very indirect way. So when we look at co-views, we are looking at items that have been co-viewed with this item. Chances are that similar users ended up co-viewing those items. So we don't really at this point, given the context that we have, that is on the listing page, we're mostly trying to look for what is relevant to the seed item and not so much to the user. On the home page, it's a different story. There we are trying to recommend things for the buyer or for the user. And that is where this sort of user to user correlation is interesting. Again, we're not doing it explicitly, like the example I gave of the user embedding that we are learning. So because similar users may click on the same things and search for the same things, chances are that in that vector space, those user embeddings will end up being very close to each other, right? So that's sort of indirectly how we are modeling similarity between users. Any other questions?
So how often does the production system update? Like, I mean, so as you keep.
Yeah, that's a great question. So yeah, right now, it depends on the model. I mean, the models are typically refreshed every few weeks. One thing, like I mentioned, is we have to correlate the data with the purchase data. The purchase data isn't typically available on the same day. Sometimes, it takes 7 days, 30 days. So we wait for a certain period. And then once we get the purchase data, we get enough training data, we can refresh the model. And we find that because of this, what we call concept drift, right? So people, the ML model may go out of sync with current purchase patterns. Let's say some new thing is trending, right? So it is important to refresh the model periodically. That's the typical cadence. Ideally, we would like to get to maybe even sort of a daily refresh. But again, that requires those kinds of engineering investments as well.
So from these trends, are there other kinds of services that you can provide to from trends that you notice? Is that a valuable
yes, it is. Yeah, and some of it is hard to do using ML purely. Some of it you require like maybe a more human curation, right? Some things you can do, like suddenly, when those fidget spinners were a thing, right? Suddenly one fine day, the sales of those things just went through the roof. So you can kind of pick up on those kinds of trends, but they're also more like seasonal things, like say there's Easter coming up or some other festival. There's sometimes curation. So on our homepage, you will find some of things which are like related to activities, summer activities, springtime activities. Those are all human curated recommendations. So we use a mix. What I talked about today was mostly the machine learned ones.
I think there's one more question on the chat.
Yeah, do we use incremental learning during this daily refreshing, or we train from scratch each time? We use, I wouldn't call it strictly incremental. We are using more like a sliding window. So it's, let's say I take the last 30 days worth of data. If I were to do that again after a week, the window would have shifted. So there's some overlap. There's some older data and some newer data. So the reason to do incremental training, I think, becomes more, I would say, more important in the case of deep learning, where you're spending a lot of computational resources to train that initial model on 100 million samples. That is not something you can afford to do again and again, right? With XGBoost models, we are able to do it fairly efficiently. So it's okay to do it from scratch, but on a newer window. But with deep learning, I think we definitely have to do more incremental learning. So as data comes in, you will do that. And you also want the network to forget some of the older data, right? Because trends are moving. So those are problems that we're looking into right now with our deep record.
So I think we are coming to the top of the hour. So, so Sriji, that was a wonderful talk, and I think it was very useful for useful insight into the scale at which these recommender systems need to function in a company like eBay, in a marketplace like that. And so, thank you very much for accepting our invitation to do this for CDSE Days.
My pleasure, Ranga. Thank you all.
Thank you.